Uh, Hi everyone, this is Serp API podcast, episode number 5. We will talk about topic how to scrape dynamic web pages, and this time Dima will ask questions and I will answer them. Uh, Myself and Dima, we work at Serp API. We scrape Google, Bing, Yahoo, Baidu, and other search engines. Dima handles developer relations. I handle engineering and marketing a bit. And Dima, feel free to ask questions.
Yeah. Hi, everyone. It's nice to be here. Thank you for inviting me to this podcast. I appreciate it. And the very first question I have right now is what is the hardest website you ever parsed? And what was the hardest part in parsing? So, yeah. In parsing and bypassing bypassing website blocks or stuff like that.
It's like I will answer in several parts because question contains several parts. Hardest one, I guess it was a mix between. Uh, and do you mean dynamic web pages or generally? Generally,
Any type.
I guess it was a mix of like not mix, but one that I liked the most was probably Google Maps, and uh, also I like scraping Walmart. I don't know why. Like I've came to scraping from dropshipping automation, thanks to you, and it's also always fun. And Walmart has pretty nice API that is like not public. Like, it's publicly available, but it's not considered public because Walmart uses it only from their own website, but they have also their API that requires signing up, but most of the day like much more data is available from Walmart's APIs that is used on their website. And Walmart itself requires a lot of like work to bypass their uh, like bot protection. They use perimeter X, and they have captchas, and they have like tons of like security measures. And interesting part was about scraping Walmart stores. I've made the Rust a script in Rust language that uses like that concurrently downloaded multiple stores. Like it basically made the request to some endpoint of a website on Walmart. Then I've extracted data from the page, then made concurrently multiple requests to each city, and then built a JSON file of several thousand of Walmart stores, and then I've debugged Walmart website to understand how they like which cookie, how they build location cookie. Actually, Amazon does something similar, but it it's a bit more on Amazon. It's a bit more complicated, but on
And
Walmart, it's
yeah,
can you?
do you also wrote a blog post about how you reverse engineered Walmart cookies? Because I remember something like that on at Serp API.
Yes,
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 we have
yes.
a post. Uh-huh.
Mm-hmm.
Awesome.
Yes, we have a blog post, and also I've published a repository in GitHub with a script that does that. And actually, we need to. It's probably time to update our database of Walmart stores at Serp API because it's probably dated. Because let me actually check. No, I don't want to check. uh, it's because it will take time. I guess it was half a year ago then when we scrape at Walmart stores, and it's time to update. And also, it's fun to write some more Rust to extract much more data.
Was it
And
hard? Yeah, go ahead.
no, please
I,
continue.
I yeah, I just wanted to ask about Walmart. One more question. But like, was it like straightforward for you to, I guess, reverse engineer how the cookie was built? Like, and what's this cookie actually do in the what the purpose in the parser this cookie? Like, I hope this
In
question makes sense.
which parser, like Serp API?
Uh, yeah, yeah. For example, if you can share this information.
Yes, like at Serp API, we like Serp API supports a parameter that's named store ID. So s- we allow our customers to pass Walmart store ID, and
Mm-hmm,
under the hood we build a location cookie and make a request to Walmart with that store, like for specific store. So, for example, when we search for yoga mats, and we want to search, and by default, Walmart searches near to proxy location, or if the proxy is outside, or if the request is made outside of United States, they output products from Sacramento, some store in Sacramento. I don't know why, just
do you
Sacramento.
think it's just a like a default location?
For like, guess yes. Like
Mm-hmm,
if for example, I can like oh no, I can't share it right now because Walmart blocks requests from Ukraine currently. I don't know why. Like same for
Home
Home
Depot, I
Depot.
guess. Uh-huh,
Yes,
yeah.
and I don't have a VPN right now.
Mm-hmm,
So how we and that's how we use it through API. We build a cookie and make a request for the specific store, so customers can retrieve products from specific stores, not from default ones, not from
mm-hmm,
some random one, but from specific one. And also not only a list of products, but the specific products. For example, I've selected a specific yoga mat, and I want to find availability and price in specific location because
mm-hmm,
it
mm-hmm.
differs from location to location.
Mm-hmm.
And where is the name? Sorry, I want to
Yeah, no
make
worries.
overlay, but it doesn't work for some reason. Uh, anyway, uh, and the second, not hard, but the second most interesting uh, situation with scraping was Google Maps. Uh, like it required, and we also have a I have written a blog post about scraping, not scraping, but kind of reverse engineering. It's not exactly reverse engineering because reverse engineering is mostly about dealing with binaries or executables, and this and and the work that we have done with Google Maps was mostly about reading the obfuscated JavaScript and understanding how it works. Uh, it was hard and also fun. Uh, so how we did that, uh, and it actually took a long time.
Something specific took a long time, or like whole parser.
Not parser, but like we
I
have
mean,
written.
Yeah, sorry.
We have written a parser, and then customers requested pagination. And for pagination of like when we search on Google Maps for something, we can click next page. And as we don't use browser, it we needed to like re-implement and understand how they send HTTP requests for the next page. And the challenge was about understanding how URL is built for the next page. And we began with manually trying, like, I've listed on the scene, like, I've created a document, not document, like, I've used text, like pasted in text editor multiple URLs to multiple requests for different pages and manually checked the parameters and then started to divide them. Like Google Maps has, it will be actually better. Like, let me share my screen and we can play with that.
Yeah, awesome.
Uh, so I can create right now new tab, Maps, Google.com. We can go to, and we can also switch to another language, United States. I'm sharing my screen window. Can you see my screen?
Yep, yep.
So we want to search for something, for example, in Madagascar. What we have in Madagascar, I don't know, like beach, beach, and let's open developer tools. So Google Maps. I want Madagascar. So Madagascar beaches. Okay, clear everything. And when I scroll down, there is a request for like maps preview place and then pb equals to long string. Like we can check the payload here. It will be more usable. And this is like pb stands for, I guess, protobuf, but it's encoded in like protobuf is file format. No, not a file, like it's a, yeah, actually it's something like a file format or encoding, I would say. And it's encoded here not in a and usually it's encoded as a binary, and here it's encoded as a string with separators. Exclamation marks are separators between different. And if you see here, we have 3M, 1M, 1D, 3D, 3F, 2F, 4F, 4M, 1M, 3E. Like so, they have several field. So this like exclamation mark and then number and letter means some field format. For example, they have strings, nested structures, integers, floats, and something else. I don't remember right now. And what I've done here is I've copied this, split it by exclamation mark, and started manually. No, not actually manually. I have used some online diff tool, and I've compared this string. For example, when I scroll down, there is
By
another
the way,
search. Mhm.
I'm sorry to interrupt you. For our users who are, my listeners who are not really into web scraping but want to understand what they're doing, So you're in DevTools network tab and under fetch XHR, right?
Yes,
Yeah.
I'm filtering my. Thank you. By the way, thank you for clarification question. Yes, I'm using browser DevTools in Brave browser. It's Chromium-based browser. I have filtered requests by XHR and fetch, and
Mm-hmm.
I've clicked on search. And actually, yeah, I've clicked on this search request. Click payload, and then it's a query string that is divided for each query and query parameter. So key value, key value, key value, key
Mm-hmm.
value,
Mm-hmm.
and what we have found is like search. So search request with this PB query parameter is an actual request that we are interested in. And we
Mm-hmm.
started to digging into how to recreate this PB URL by using our by so we have only several parameters. We have latitude and longitude, zoom level, and we have query, and we have some extra parameters, and from that we want to build this PB URL, and it will respond with something like this, and from uh, like it's JSON with several
Mm-hmm.
fields, and those several fields list all of these places. For example, if I click on this place and try to find this Kimoni Beach Moron Dava in this response, it's somewhere here. So we have data for its uh, sorry, for its coordinates,
Mm-hmm.
title, also some images. So it's deeply nested JSON response. And but the story here is about kind of reverse engineering this. Uh,
Mm-hmm.
so I've listed several request parameters on the single page in my text editor, manually try to understand how it's built, what is different, and then after I understood what is different, uh, like let me actually go through the blog post. Serp API blog, if it's here. I'm not sure if it's here. I should be better prepared. So we don't even have blog post here. It's probably somewhere on other platform. Okay.
Mm-hmm.
So what we have done, I've looked at, I can actually show here. So when I hover, so in the network DevTools, in the DevTools network tab, I can hover over initiator, and it displays call stack, like functions that are called one after another to make the specific request. So to understand how the and it's not clear how these parameters are built. Like for example, I'm not sure if I should actually explain
Yeah.
that at that level. Uh,
Uh, let's maybe like explain. Could you explain to people where to possibly look to solve this issue.
Okay.
Not actually explaining the whole process, but like pinpoint to like places.
Yep. So then it's actually will be a good idea to go into sources tab in DevTools. So the first step is to try to understand where the data is being retrieved from. For example, I open network, scroll, nothing happens. Scroll, something should happen. You have reached end of the list. Okay. Let's search for not beach, but road. I don't know. Maybe let's search for road. Not here, but in Madagascar. And no roads on Madagascar. That's perfect.
Maybe we should clarify it in the query, like roads Madagascar. I'm not sure.
Yes,
Yeah.
thanks. And so I scroll down and I see another request that's named search. Like Google usually names search like search request whenever we want to retrieve the search results. So I immediately look at this. Then I go to preview or click like I select element on page uh, and it's like I use keyword binding like Control Shift C. Here I see that this place has a name like Ibis Antanala blah blah blah, and I want to check if it's actually the request that contains the specific data.
Yep.
Clicking
Makes
Control
sense.
F, pasting here, yes, it's this request. So I have found, like actually previously I could use Control Shift F search, but right now it doesn't work. I don't know, like several releases ago, or maybe several tens of, like more than several releases ago, Chrome stopped searching in network requests for specific data. Previously, I could write anything here, like its name. Like when I open developer tools and click Control Shift F, or just click search here, I could search for text, and previously it searched not only in HTML but also in all of the requests are done, and it was and also in JavaScript sources in any text, so in any response from some request from all of the requests that are recorded. But right now it doesn't work. But previously it was much simpler because it helped a lot. And right now I have to dig more. So we have found the request, and right now, and when I click for payload, I don't understand, like, have no clue about what it actually means.
Yep.
Like
Yep.
how to recreate this PB? Like no way. I look at into like I went to I have used it probably grep up and source graph to search for this PB, and not only for PB but Google.com
And
and
what is grep that app and source graph?
uh,
What is it for?
source graph and grep app are searching over public repositories. Like grep app searches over GitHub repositories because GitHub search is uh, not convenient. And source graph searches not only on GitHub but also on Bitbucket and GitLab and probably over STHT. It's some distributed Git repository. Uh,
Got it.
Not repository but Git hosting. So here we want to search for PB, and also I went to Google and changed language to English and searched for something like Google Maps PB parameter. What is that? Like, oh, the code, and it was this question or something like that. And there were several really good answers on Stack Overflow. Probably this, and look at that. Like, how good is that question? Like, it's so well structured, not as usual random thought
Yeah, it's
like
right.
like like thought dump on Stack Overflow, but usual it's as usual. But here's a well structured question. Like I want to answer this question, and there were several really good answers, probably. And here people explaining what like here you look. It's a nested
Mm-hmm.
means nested structure probably, and nested structure, and this means D is decimal, decimal, decimal. It's
So
something. Mhm.
I'm sorry to interrupt you. So this is like what I'm looking at is like really reminds me of JSON for some reason.
Because
Like,
it's indentation.
yeah.
But it's like it's data structure that is just encoded in a different way. Like instead of
Mm-hmm.
having uh, like multiple nested objects that are in JSON or in Python object or like Ruby hash, whatever. Here we
Mm-hmm.
have different ways of telling, and also they have a parser, and
Mm-hmm.
just different way to tell that something is nested, something is decimal, something is a string, and if we if we actually uh, it's probably base 64 encoding
And A to B function is
or
what is
B2A.
doing.
I'm always forgetting what is that. No, it doesn't work. A to B is the code base 60 from base 64, but it doesn't work right now.
Mm-hmm.
I mean, doesn't work right now because it's probably not base 64, I'm doing something wrong. But here,
Got it.
yep, you see nested data structures like,
Yep.
and
Interesting. Uh-huh.
another person explained it, and they were. So I've looked into like some GitHub repositories. This is also good. So they listed what is integer, what is float, what is double, what is boolean, what is string, and there is another type, probably Z, that means nested data structure. So in some of the related questions, there was, yeah, you see,
Mm-hmm.
it's how like data different data types,
Mm-hmm.
and they explained. So at some point I have found I also played with this code in developer tools on Google Maps, and at some point I have found GitHub repository. GitHub, how it's named? Google Maps PB, the code. How it was named? Protobuf Dart. I don't remember right now, but there was some GitHub repository. Actually, I haven't checked this one. It maybe it actually works. Let's check the source. Google Maps data parameters parser classes M is native data structure. Find latest incomplete. GMD waypoint road. Whoa! Interesting. So it's actually encoding PB parameter. Really? How to use it? So demo page demonstration. Maps URL. Right. Not parsable. Why? Why not parsable? At some point, it will the URL will it will have data, and what we are interested in is data. Row parsed parameter predefined test URL. What it means? Map type pin row parsed and this mean waypoint with coordinates, but that's not what I want. Method, but it's also interesting. Like it has a mapping for road, method of transport, basically some kind of parser. But I have found not this, but another repository in GitHub that is written in Python and it uses Qt5 browser. So I can. I have pasted URL from Google Maps and then and then navigated on the page and it tried to collect data structures that collect and decode data structure from Google Maps that were used on my usage session, but it didn't work. Maybe right now it works, but I don't remember how it was named. But I can
I
actually. Sorry.
I guess it's not like pretty
Yes.
necessary to show right
Yes.
now. Okay.
So I have searched on GitHub,
Yep.
found some tool, found some scripts to split request parameters from a string to a nested data structure. Then I tried to understand what, like I was getting familiarized with the data. Then I was interested in actually how the URL is built, and then I've used developer tools. So hover over initiator and reading the stack backtrace. So renders, like render what we have request animation frame, render, send, start, like send is probably too low level, but we have start. What is start? Let's actually let's format this code and go to network again. Start. So it sends request, uses some RPC method name, payload. Let's click the breakpoint and then scroll down. You have okay, road, Madagascar. What else we have on Madagascar? Oh, I have zoomed in and it's updated. So we can now, and right now we are in developer tools. So let's actually use another window. Can you see the developer tools?
No, no.
Let
Only.
me change screen sharing. So I want to share entire screen actually. Sharing, and we have this stuff here.
Yeah.
So here is debugger in the developer tools. So we can click. Oh, we have payload. So payload is PB. So this payload is with string. Okay, sounds interesting. How it's being built? Where we so this payload. So if we have this payload, it's not a random name. We can search for this payload. Oh, interesting. So we have a constructor, and this payload is assigned to A. So disable this breakpoint, click in resume. Oh, interesting. So we can right now check how the URL is built. So we have some request and A send A, where A is coming from. A is coming from here, send here. A again, no, we have so ABC, A this OWF. What is AOWF? Let's check this function location. Oh, encode URI component. Interesting. Interesting. So this is how this parameter is built. Let's deactivate the previous breakpoint and resume. Okay. So we have some array. Some array of data. Let's inspect it here. Some array. It has like localization, nested arrays, and it also have container ID. So this is probably settings. This is some nested list. We don't know what it means. Trying to find some meaningful data.
Yep,
And
makes sense.
it's nested some road model. So it's a query. It's a query, and probably there are also. Oh, what is this? Interesting. They updated their JavaScript stuff, like because we have written the parser and we reverse engineered the request parameters 2 years ago, and probably right now we can pass even more data, or we can. Oh, we can re-implement this function in Ruby, and instead of right now we have a string, and we have several placeholders on a string for search query, for location like latitude, longitude, and altitude. We convert zoom level to altitude, and right now maybe we can get more data or pass more data. Interesting. What is this? Okay, so at some point we are finding that we are passing some data.
Yep.
And to not like if I will explain the entire process, it will take several days, I guess. But
Makes sense.
what we have done, we have found like moving parts of a URL. So for the same request, when we paginate or when we zoom in, zoom out, there were changing parts in this DB and not changing parts. We have found like variables that we need to put for specific page and for specific search query keyword.
Makes sense.
I mean keyword,
Yep.
and then let's just
And
stop
the
it.
process was like pretty much the same, like trying to understand how the URL is built. was built?
It was actually like I've done exactly what I'm showing you right now. So I found out that some array is converted by using like what is WF? What is that? Like function location W. Whoa, what is that? Let's prettify it. Wait. So WF is what it means. Okay, we are converting this stuff. What happened? So we have oh interesting. HA is some like you see we have B like we have A parameter is like data that we want to encode. And we have B parameter that is probably how to name it? I can't provide the word for that, so it's something like a sequence of characters, uh, like not an algorithm for encoding, but something like an algorithm for encoding. I don't remember the correct word for that, but let's and
Yeah, no
then
worries, no worries. Yep.
mhm. So there are several functions, SNA and UNA. What is SNA? Let's check. SNA for A is some number. Don't know what it means. And UNA for this stuff is what? Zero. It doesn't work right now because we need to. So we have to execute this code, and now we can execute this code. And if I will execute it here, some number, what it means. And if I execute it again, so at least it would respond to the same. Whoa. What is
So,
UNA?
so this is like
And then C
not
join. Oh, you see? Interesting.
interesting.
It's an array, and then C join exclamation mark. C join space. Okay. Interesting. GCID, and we have right now. So for sure, UNA encodes or DEG. Oh, so we have a it's an array. It's probably a proto buffer that the Google Maps page have retrieved from Google Maps backend. Like as we have seen previously, here we have some RPC method name like remote procedure call. It's for sure it's like some gRPC backend, and it's named request scheduler channel. Like let's search on Google or on source graph. What is request scheduler channel? Nothing. Google.com request scheduler channel. Okay, nothing. But we are interested in UNA. UNA is I'm right now. I'm starting to yes. So it will call some function named TNA, and Z means nested structure, and others mean like object, and it recursively call UNA. It replaces like something with another stuff. It shifts right, values, and basically it decodes data that came from. So we have our A array, and this A array. So UNA calls ZJ, and then it calls for each array element, it calls TNA, and TNA does all of the work. So it returns actually this nested array. It decodes
Yep.
it decodes this into this array, and then we just string join. And at the beginning, I wanted to find maybe on GitHub there is some code. So if we have a function that decodes data, then we should have a function that encodes the data on the Google backend. But at the point, like at the moment when we scraped the data and reverse engineered the pagination, I haven't found the code. Maybe source graph wasn't there, or maybe my Google few my Google skills were not that good. I don't know. But what I've done, I've placed the debugger here, then click it here, and then use it step-by-step debugger. I've checked what it means. Like here we I'm clicking F10, and F10 means what it means. It means step over the next function call, and F11 calls step into. I'm right now stepping over and checking like here. You see some counter B equals then VNA, like what it is. It's I, then we check type of OH. It's for sure it's like it's decoding of data that came over the wire. And
Yep.
yeah, sorry, I'm trying to right now think maybe I should try to find something on source graph that does something similar.
You always did you always like
Hmm. Bytes per
did you usually use Source Graph to search parts of the code?
Yes, it's usually better than GitHub searching than Google. Like
Hmm?
if source graph doesn't work, I use what is it? Like you see the same code, 1263, 100.
Mhm.
What is this? Buffer. It is some well known. Same.
It's some sort of algorithm.
Yes. UTF-8. Really? The same code. Char code that. It's the same code. Like if I convert the same code. Like let's try to
So
convert.
technically we can use
Yes, you see.
you can use the same code. Yep.
So we like so this function like it's interesting actually because at that point 2 years ago I didn't understood what happened here, but right now it's probably inlined function named UTF-8 right. It's the same, like it's the same, just optimized by Clojure compiler, but it's UTF-8 right. And if we have UTF-8 right function, so we have a string buffer. So this array A is a string buffer. Which part of data we are actually passing here? So we have our call stack NSA, TNA, UNA, and we pass to TNA HM, TNA HM. What parameters we have? We have A, B, D. D is an array. It's a result. C is, what is C? I, 6. I don't remember right now, but it's interesting. If you have UTF-8 right, React PDF browser, CPOR. What is CBOR? Code point. UTF to bytes. It's UTF to bytes. Why do we write UTF to bytes here? TNA returns, so we have D return E. E, what are we trying to do here? So, it's probably should be covered over another episode or another show of Serp API. But here was the process. And then we can deactivate breakpoints, click F8, and check if it actually works.
Awesome.
So, yeah, please ask.
Yeah, thank you so much for pretty much showing the basically like I think like 70% of work or maybe more. Like
And
it's very interesting.
So that was part of understanding how it works, because I wanted to understand how the string is built based on some parameters. So we have some parameters like deeply nested arrays, and then we have some string with encoded data. And I wanted to understand how, first of all, it's built, and then, like, if you look here, we have like categorical injection, then roadmap, and at some point here we have latitude and longitude. I don't remember. Let's search for it.
I guess this is a very interesting question to you and topic.
Yeah, I like JavaScript and I like developer tools.
Well, maybe we can split like stop process here and maybe record another live stream about like specific for this task for this type of topic, because I'm not sure if
people will be able to handle that much of information.
yeah, but
Okay.
yeah, yeah,
Uh,
and
then
yeah. I have a question, another question. Like you show in Google Maps and browser automation. You said that Serp API, I guess Serp API never used browser automation before.
No, we have
Hmm.
used, and I want to finish my thought on the previous
Yeah,
topic.
go ahead.
So if we are going to split this into next future episodes, then I want to explain what we will cover in the future, and then I will answer your question that you have asked. So for the Google Maps, I have reverse engineer debugged it and trying to understand how it works, and then uh, there were like latitude and longitude GPS parameter, geo coordinates, and Google Maps in the URL has latitude, longitude, and zoom level. But when they make request to Google to their backend, instead of zoom level, they pass uh, altitude. It's like height over the ground. And I have found several formulas in Google Maps sources and debugged it how it works. Have written down on the text editor all of the functions. Then I've tried to understand how it worked. Then it minimized it down to several mathematical formulas. Then I have used my whiteboard and Wolfram Alpha to simplify formulas. I have solved differential equation. Like they have integral, not different. I don't remember. Like they either had either differential equation or logarithmic equation. I don't remember why I had used differentials, but basically I have used my whiteboard, have solved mathematical formulas, then used Wolfram Alpha to simplify all of the formulas, then written Ruby code, written down Google Maps blog post with all of these formulas, screenshots, and that was it. And probably in the next episode, hey, smoking every day. In the future episode of this topic, we will start from this and we'll try to build the URL for the ZPB parameter. We will dig into source code of Google Maps front end, how they build, how they convert latitude, longitude, and zoom level to altitude. And it's not that hard. Like the hardest part was about understanding specific moving parts.
And yeah, and you were saying about Wolfram Alpha,
Yeah.
Alpha. It's some application or
Yes,
software.
it's a website and also desktop application. It's something like MATLAB, but much better. Like, for example, Google provides questions for specific, or Google provides answers for like live questions
Yep.
or something like that. And Wolfram Alpha provides questions for. Oh, we have chat here. We have Amir Khan and Milosh. And Amir Khan actually. Cool. Let's show chat here. Mm.
Hi, Emirhan. Oh wow, watching on
Cool.
Twitch. So cool. Oh,
That.
we can actually like give links.
Uh,
Oh, lead.
yeah. We can like use like as real streamers, like pin some chat messages. Yeah, hey Milosh. Hey everyone. We
Hey.
can have an actual discussion like in a live stream, not like not like talking to the monitor to the desktop but talking to actual people. Cool.
And it's actually very interesting. You were saying you created you searched a few formulas, mathematical formulas to solve this uh, issue or problem or this task, and it's very interesting and like in web scraping formulas, mathematical formulas, very
Yeah,
unusual.
let me actually have some spoiler for the next episode because it's really fun.
Yeah, yeah. Go ahead.
We go to the developer tools and do Google Maps and open sources, and then we search for like I don't remember, but I remember that some formula contained a radius of Earth, and if I will search for a radius of Earth and then will search for the specific value on uh, source code, then I will find out specific function. So Google Maps for Earth radius.
May I interrupt you? I have a. Can you make your screen share like full screen? Because on my
Yes,
part I have a like huge part of my text messages, I guess, or
sorry.
comments.
Yeah,
So this, maybe
sure.
it's will be
So
better for
chat
the
overlay.
viewers.
This or
Yep.
maybe this
Uh,
way.
yeah. Both ways works great for me.
Cool. So hide this developer tools, and we can actually scroll like this is how actually I've done it. So I've started from this and used page down to scroll over everything. So what is it? Don't know. Then go below. Interesting. Looks. What flow? This looks like what we are looking for. I don't know why, but
And just to clarify, this is for the next stream, right?
yes, this is for next stream. So I have dig it into. Oh yeah, this is the Earth radius, as I remember. So Earth radius. Yeah, something like that. So it's probably Earth's radius, but spherical. And I have written down in my text editor several functions like this one. Look at where it's being called, and then converted all of the function calls into a single function with all of the function calls inlined. Then written down by hand mathematical formula, then tried to simplify it, tried to understand basically what happens, tried to and then use it Wolfram, pasted entire formula to Wolfram alpha. Here it looks like this. So pasted entire formula here. It simplified my formula, and then we got what we have right now. So a simplified formula to convert zoom level to altitude or altitude to zoom level. I don't remember like what exactly requires to Google Maps.
Got it.
We will cover it in the next episode, probably, and it will be named either dynamic web pages web scraping or specifically Google Maps pagination reverse engineering, something like that. And
Very
I'm
interesting. Yep.
and Miloš actually showing formula, and it's a part of our pod. Cool. It's cool to have real audience. Thank you, Miloš.
And for someone who doesn't know who Miloš is it's
Uh,
a Serp API engineer also, as well
yeah.
as Emirhan. And Ali is a customer success.
Mm-hmm.
And may I ask you another question?
Sure.
If we still have time.
Yep. We have time. Like we have, like I have energy to tell more because I have like answered what I have wanted to answer previously, and you have asked a question, and I haven't answered it, and I actually forget about the question.
So I had a question about if Serp API before used browser automation. You said no. You said
Mm-hmm.
no, and like another question is when it's a good time to use browser automation. Like, I mean, if there is, if at some point there is no way to scrape the data, like even as you showed by reading JavaScript code and reverse engineer it, is it a good time to use browser automation at that point? And will it be efficient? And uh, can uh, can we somehow speed up browser automation? Like, yeah.
Uh, so first question was about have Serp API used browser automation? Yes. Before it was probably in 2018 or 19 before I joined Serp API. like the first version of Serp API was using Phantom.js. So Julian, either Julian or one of the engineers were before like any of us here, but probably Julian has written a script, and we were using Serp API was using Phantom.js. Instead of plain HTTP requests, we just made a request to specific web page, and then we also had a captcha solver. So instead of dropping requests, we have used, I don't remember, like you can actually check the code base because we still have Phantom.js based code in Serp API or at least in Git history. So uh, we will probably, if I remember correctly, that Phantom.js driver was using uh, machine learning. Yeah, it was using either machine learning like model or some API to solve captcha, sound captcha, not images captcha, but it used some API or some browser extension. And actually, right now there is on GitHub some GitHub extension with several GitHub stars, with several thousands of GitHub stars that uses Google API to solve Google sound captcha. And we did exactly that previously. uh, so we were using Phantom.js, but we
Right
started
now, did you mean right now?
previously. Like
Previously. Yep.
sorry. We were using previously Phantom.js, but then uh, at at that point in the past, Serp API supported only Google, and there were no concurrent requests. But then, like if you read Serp API code base history in Git, you will see that at some point, at the same point when uh, we drop it out support when we switch it from Phantom.js to plain HTTP requests at this, like it's near similar time. We switch it to concurrent requests to concurrent HTTP requests, because previously we were using like requests one by one, and actually at that point in the past we were or I may be wrong here about maybe we were using concurrent requests with Phantom.js. I don't remember. I have to check Git history, but we were using a like single fat powerful virtual machine on some cloud hosting, and then we switch it to multiple servers and spread the load, balance the load, spread the load. And yes, right now we are not using browser or automation, but we will use it for our global positions feature. Uh, like if you have checked it, but that's like out of topic right now, I guess.
Yep.
And the second question was when it's good idea to use browser automation, like basically to use browsers. And your third question was how to speed up. I
Correct.
want to answer the third question and then second one. So how to speed up? If we I can share my no, yes, I can share my screen, or I can talk a bit. No, I will just talk. There are several projects on GitHub. There are two projects that are named Browserless. Like one is software as a service, and the second one is a Docker image. And so there is browserless.js.io. Let me type something into chat. Browserless.io. Let me actually check if it's correct. So there is browserless.io, and there is browserless.js.org. So there are several projects. So browserless.io is a software as a service. Like it's a Chrome as a service. So
Mhm.
and browserless.js.org is like convenience methods over like there is a puppeteer. It's a Chrome developer CDP, Chrome Developers Protocol API in Node.js, and browserless is a wrapper around puppeteer. Uh, it uh, it it has pretty nice defaults, browserless.js.org. So it has, first of all, it has live debugging. So when you spin up Docker image, it can open a browser with on right, like it splits your browser window to two parts. One is uh, code editor, and second part is video stream from headless browser inside Docker. So you can write script and actually see what's happening, and basically visual debugging of your browser automation. It's something looks like cypress.io. Cypress.io is a test automation, but Cypress allows recording, and browserless also actually allows recording of tests and of entire session. So, and also browserless provides convenience scripts to block requests, like block images, block unwanted CSS, block unwanted HTTP requests, like puppeteer itself provides it. And browserless.js.org have it pre-configured. So when you go to some page by using that browserless stuff, it already cuts down number of network requests. So because most of the time browser automation being slow when we wait until some response, because we have to, like when we use browser automation, we have to wait until something appears on the page before we can interact with the page, because like it's how websites work, like dynamic web pages work. And when we block some requests, the page is faster, so we can speed it up by using that. Yes, and Emirhan tells that it's about test flakiness. So most of the dynamic web pages automation are flake, because flake means like it fails time to time, and it fails time to time because sometimes and network requests are not like predictable, like, and by reducing number of network requests we can increase predictability of our script, I guess. And that's the reason why we actually switched from Phantom.js to plain HTTP request, because we make a request, it either fails or succeeds, or it times out at some point, but it still fails. But with browsers, we have uh, network requests, and we also have a page, and we have to check if it's like properly rendered, if it's inside the viewport, and only then we can click on something. And it's like it's not that fun. Like it's like comparing back-end work and front-end work. Like front-end work is always like it's nice for some people, but for backend people it's like not that nice, because it's like the reverse. Front-end people usually don't like concurrency and digging into something like, and there are also full stack people who are fine with everything. But like I've explained the speed up part, so we we can go to browserless, and they have a Docker image, packages, browserless, PDF, screenshot, PPT, SRC. I'm not sharing screen. Yeah. Let me share my screen.
And
Let
could you also collapse comments?
chat. Yes, I can. So I'm sharing my window browser, collapsing comments.
Yep.
We see it here. Let it be
Nice.
like that. Sure, API logo is too big, I guess, here. Let me hide it right now. Uh, oh, it was too loud. So we have browserless package on
Yep.
GitHub, and we have packages driver .js. It's basically a wrapper around ppt, and like here we can check specific flags, specific network interceptors that can improve reliability, like, and reduce flakiness. So for example, they have that number of default arguments, and that arguments are needed. Can also should I increase font size?
For me, it's fine actually.
Okay. Uh, so that default arguments are not only for reducing flakiness, but also for being able to run that headless browser from Docker, from AWS Lambda, from like anything. And also, I remember they had either enable WebGL or something else. So they had some Chrome flag to be able to stream. Let me actually to showcase it. So if we go to,
And to clarify, this is about speeding up browser
yes,
automation.
this is about speeding up. Yes, so we providing specific flags. We are providing specific flags to Chromium. And also there were some network interceptors. I don't remember where they are. Package
Okay, that's not a
browserless,
problem.
lighthouse function, error, CLI, benchmark devices. Let's search intercept, because PPTIR has network interceptor. So packages go to, yes, and also media codex evasions. So page on request, what we have? Built-in evasions, built-in like you see, browserless has built-in evasions technique, built-in ad blocker, and yes, so this is what we wanted to do. So it has built-in ad blocker, and it will for sure speed up navigation on any web page, because like ad blockers, most of the reasons why websites are slow, because of of ad block, because of ad scripts, because
Yep.
they are improperly used on pages. They like website performance is another topic, but ads are bad.
Yep. Got it.
So,
Interesting.
and if we search for ad block here to understand, like we have ad block parameters, so we want to understand how they are actually blocked. like if we are doing that, like if anyone wouldn't want to use browserless or will want to understand how browserless works, or will want if it's the word, like if anyone would want to copy only specific parts of browserless into their puppeteer or selenium scripts, it's the way. So it injects specific stuff, inject style, like scripts, modules, media type, emulate media, animation. It can disable animations, post modules. Where is debug? Evasion keys. What is evasion key? So it can do like multiple stuff, multiple interesting things. And
Got it.
browserless is cool. And stop sharing screen, showing chat. And
Yep.
Miloš is telling that font size is fine. Thank you.
Awesome.
So your question, like I have answered how to speed up, and your second question was about when it's good case to use browser automation to scrape data. Like for example, when we scrape like Google Maps, it was much simpler to use headless browser instead of reverse engineering pagination, and the same is for like Google Events, Google Jobs, what else, and some other services I don't remember right now, and DuckDuckGo, and for something else. And it will be much simpler to use a browser, like make a request, scrape the data, because under the hood we also like we extract data, but also we kind of like we don't execute inline JavaScript, but we extract, like we emulate execution JavaScript execution. So we extract data from inline JavaScript, and inline JavaScript are just script tags in the HTML that we initially retrieved. So we extract the data from inline JavaScript. We have 6 viewers. Old school. So we extract data from inline JavaScript, and then some parts of the data we extract by using regular expressions. Some parts are just JSON inside script text, so we evaluate not evaluate, like we parse the JSON and then only map the data. But there are parts when specific parts, there are parts when as specific parts. There are cases when, for example, Google Images and like carousel on top of Google search results.
Yep.
It in or some parts of knowledge graph. Google search engine results, Google search page executes JavaScript that inserts HTML to the page using JavaScript. And we extract that HTML structures from inline JavaScript, and by using our HTML parser, parsing that HTML and inserting it to the page. So we emulate JavaScript execution. And it's like extra work and also extra time. Also, another like challenge is we like not Google encodes UTF, like Google encodes string in multiple formats, like binary encoding, hex encoding, octal encoding, and it happens on the same page, like multiple, and it works because it like JavaScript uses V8 most of the time, like also SpiderMonkey. But
And
JavaScript engine, like uh, when JavaScript engine evaluate encoded string, like hex encoded parts of a string, decimal encoded parts of string, it can handle all of that. But Ruby and Python can't do that. So it's fine. Like for us, it's extra challenge to also decode hex encoded or like or decode improper in not incorrect but complex UTF symbols, like emojis that are made from several parts. So there are several multiple challenges of extracting data from HTML, from inline JavaScript in HTML, because it requires decoding and it requires like like kind of also reverse engineering. If we could use browser, like we could use browser, but we don't use that right now. It would be fun. I guess at some point we will do that. We will, I guess, at some point in the future, we will spin up a cluster of browsers that will be load balanced, and we will talk to them like it will be kind of microservice or a service, and from our Ruby servers we will talk to them, and so we will get HTML and it will be some rendering service. So like not rendering, JavaScript execution service. So what we need is to evaluate JavaScript. We need to load the page and evaluate all of the JavaScript. So we don't have to extract data from inline JavaScript. We don't have to decode it. We don't have to do multiple like complex things. Like they are fun once it's solved, but they're also like like hard. And for example, Scraping Hub on GitHub has I don't remember the name, but they have a Qt5 browser that has they have a wrapper, like they have a HTTP service, uh, open source HTTP service that starts a Python server, I guess, and that opens a Qt5 browser that renders JavaScript on HTML and responds with rendered HTML. So exactly what we want. But if we would use ppt, it would be, or not exactly ppt, but like real browser, like Chromium or Safari. Actually, Safari WebKit is faster. Like there is another topic that is interesting for me. Like there is a so V Node.js is built on top of V8. V8 is built on top of WebKit, and
and
there is a
V8, what is it?
it's a browser engine.
Yeah,
JavaScript
it's
run.
just for viewers. Yeah,
It's JavaScript runtime, and right now we
yep.
have 3 viewers
I mean, for
because
the future viewers.
no, I mean I'm talking about that because I'm getting tired a bit because
Yeah.
I'm talking too much. So and I'm talking about not related topics. So it would be nice to not use browser automation, but use JavaScript runtime that can that can evaluate JavaScript in HTML page and return HTML with evaluated JavaScript. Uh, that kind of browser automation would be nice for me. But if we would talk about like using browser entirely, I don't know. Like I've seen some commenters on Reddit who told that it's simpler to avoid to bypass blocking of specific target so specific websites when using browser automation. Like there is Chrome undetectable repository in GitHub, undetectable Chrome or Chrome undetectable. I don't remember how it's named. And there are several others. And people claim that it's more efficient than using proxies, or maybe we can combine using proxies with that browser, and if it will be like 90% 90% success rate comparing to our like 80%, or like it depends on the proxy, but if it generally will increase success rate without making things more complex, it will be fine.
Interesting.
And I guess this question should be like we can discuss this question again in the future episode, because I'm getting tired for real. Like either we can make a pause, and also I have to answer phone call, and I don't know how to do that right now during live stream. So let's wrap up.
Yeah.
Oh, I know. I have to just send some money to my wife. Sorry. Do you have other questions right now, or?
I only one question, like
Mm-hmm.
final one. Uh,
Mm-hmm.
like only to I want to ask you to summarize. Like, uh, do you have an algorithm of steps for viewers who are only who just starting in web scraping? What steps they should do in order to like scrape like, for example, static, let's say static and dynamic websites, like summarize steps like first this, look at this, then look at this, and then look at this, like stuff like that.
I have to actually answer the phone, or maybe. Okay, steps. First step is to learn front end, like for real. This is the simplest way for me to understand, to scrape the data is to like I've came to backend from the front end, and I've used to developer tools in Chrome, and I've used to debugging web pages. So the first step would be learning debugger, and there should be some reason to learn debugging. And the simplest reason is to actually work on some front end project like that have some bugs, so you you're not uh, randomly like digging into one or another thing, because scraping static websites is like simple, just use like selector gadget, but Chrome extension or bookmarklet, JavaScript bookmarklet. But if we are talking about like dynamic web pages, this like the must have is to use like learn developer tools. And to learn developer tools, the simplest way is to learn front end and work on some front end project, like debug front end project. uh, I don't have a like scenario on how to learn debugging. uh, Basically trying to fix things, or trying to understand, and like, or trying to re-implement something. So the first step is to learn front end, because web scraping also requires CSS selectors, and to understand CSS selectors, like the simplest way is to write some style sheets, because you will understand specificity of selectors, because it hurts a lot. Like specificity of selectors is like is a like separate skill, and like for real. Also, Ali has a question. Like we will cover it right after this one. So first one is to learn frontend and like write some frontend code, uh, write some project, frontend project, and it will that will require no like and use don't use UI kit for first time, because with UI kit it's simple, like you just use some components and that's it, like no need to write CSS. But when you write CSS and write several like components, widgets on the page, it will require reusing CSS rules, and reusing CSS rules will require understanding how how CSS selectors work, and how CSS not how CSS selectors works, but how to write CSS selectors that aren't broken when you put elements outside of its context when you written it. Hard to
Yeah.
explain right now, but when you write CSS, like it's like well-known problem, and there are like multiple ways to avoid this. Like right now, the most modern is CSS models or CSS modules. Before that, there was like naming conventions like Atom CSS or BAM from Yandex, Putin Huila, by the way. Then like
Agree.
multiple things, and so write CSS, write front end, debug front end, and you will have to use like developer tools. And when you will use developer tools, then you will understand how to debug your code, how to debug your style sheets. Then write some dynamic parts of like add some dynamic parts for your application, like make requests, and make requests like uh, concurrently, then because it will require debugging, because concurrent requests from frontend are always like from the at the beginning they always work not in a way that expected, and it will require checking network, making breakpoints, and when you make breakpoints, you will understand like and also what's important about debugging. At the beginning, it's simpler to debug with console log, but then when at some point it becomes too slow to console log reload, click, then it's much simpler to just put a breakpoint and use hotkeys like F10, or I don't know how which hotkeys are used on Mac or on Windows, but just use hotkeys. And when debugging, it will require understanding like how like the flow of the application, and
Yep.
that's probably it. So have some project that will require debugging, and that's it. I don't know, like for example, when I right now look into some code, like for example, when I have debugged Nokogiri and libxml, I didn't start from writing C. I started right from using GNU debugger. So I started right from debugging, not from writing console log and stuff. And I like barely understand C, but still I understand debugging.
Interesting.
And something like, and also for me personally, like I like stories of Sherlock Holmes. Like for me, and there are there are multiple people with multiple conference talks who who compare Sherlock Holmes and like who talk about Sherlock Holmes stories and debugging in a single talk. And for me, it clicks. Like I like that process of understanding how things work. Like when I read when I use it to read Sherlock Holmes stories, I like reminded like some parts of my debugging experience in software, and don't know, a different point of view.
Interesting.
Does it answer your question about how to debug? And also, in DevTools, in Chrome DevTools, there is a thing like you can format code. So when we
Double
you
brackets?
yes, because most of the code. Yeah. Emirhan, are you telling about Sherlock Holmes? Uh, anyway, what cool. So we have some delay. Uh, it's better to format code because reading minified code is hard. Like it's much simpler
For sure.
to read for formatted code, at least somehow formatted. Does it answer your question?
Yep, yep,
Cool.
yep.
And Ali uh, have asked, is it better to use XPath or CSS selectors? Why industry tend to use CSS selectors more instead of XPath? Actually, like it's interesting because it's interesting question because all of the tools translate in CSS selectors to XPath because all of the tools are using libxml or some sort of competitor of or alternative of libxml. So all of them are using this like the same algorithm. So yeah, all of them use the same algorithm to convert CSS selector to XPath and then traverse HTML by using XPath queries. And also in like in testers in web test in in community of test quality assurance like testers of web pages like who use Selenium, expats are like having dominance, so most of the testers are using expats because they're more reliable. There is more, not more reliable, but syntax of expat provides it's how to say, not it's not more strict, but uh, it has more power. Like it allows to traverse the, like it allows to select some node, then go to parent and select all of the specific elements that have specific stuff and that node has. So it have much more powerful filtering comparing to CSS. And for example, modern versions of CSS. By versions, I mean CSS3, CSS4, CSS5. Like in CSS4 or in third, they have added pseudo selector has. Uh, Before there were no such thing, and in CSS4 and CSS5 they add into the standard even more things to be able to select like relevant elements. Like for example, CSS3 have added like star, circumflex, and sign, and it means, and also plus sign, so div plus a or div star some class name, and it allows to select to write a CSS selector for that will capture more elements. But by using XPath, it's like available right now. Like, but unfortunately, like none of like libxml doesn't supports only XPath 1.1, but there is XPath 2.0, and it doesn't. I have seen only one Golang library that supports XPath 2, but anyway, all of the libraries that extract data from HTML translate CSS selectors to XPath. And Emirhan says that CSS selectors are still poorly implemented. Like there are many escaping problems. And for example, this has text equals to something is translated to XPath query, and by using XPath queries, like there is much more power. It's like
It's
yeah,
like writing an expression.
yes, it's like writing an expression. It has much, and it can be minimized down to much more concise XPath query, and also like I have raised a year ago an issue in Nokogiri repository. Their algorithm of translating CSS selector to XPath duplicates parent nodes. I don't remember, but from what I remember, it has some duplication, and by minimizing that XPath query manually, I have sped up Nokogiri usage by 10 to 15%, and I haven't implemented it in Serp API. I have not submitted a pull request. We only discussed it with Mike in issue, and we stopped it. Mike is a maintainer, like primary maintainer of Nokogiri, and also he is director of engineering at Shopify. And so yes, but why, like, to answer like the like part why industry tend to use CSS selectors more than XPath? I guess because right now the trend is to use browser automation and to use PPTIR, and all of the front-end people are using PPTIR. Front-end people know CSS but don't know XPath, and just using what's more not convenient. What they people use what they know how to use. It doesn't mean it's actually the most efficient, but at some point they switch to XPaths because it provides more power. But at the same point, CSS is in multiple ways. CSS is more concise. For example, we can write dot class name, comma, dot class name, comma, dot class name, comma. It's short. By using XPath, it will be like 1000 character string that will use some string manipulation, because XPath queries can only query over entire value of attribute, and to query only if you want to query over only like, for example, div have 3 class names, and we want to match class names that second one in the attribute value. And if we will write XPath that looks like like class equals to something, it won't work because it will match by entire attribute value. And Nokogiri and Beautiful Soup and also Parcel, they use string manipulation, so they wrap class name around, they prepend and append space, and also have a function that names text containing and match that way. So in some point, like if we use only class names, it's more concise to use CSS and translate it to XPath. But if you want to have something more complex, it's simpler to use XPaths.
Awesome. In your opinion, may I ask you like a final question about XPath and CSS? What is in your experience? What is faster?
It's translated into XPath, so don't know.
Got it.
I don't know how it works in JavaScript runtime, like V8 or Spider Monkey or whatever else. But when we use Beautiful Soup Nokogiri Parcel or something else, I'm not sure about Rust or Golang libraries, but it's
Makes sense.
like because all of that libraries are anyway working with XML, like they treat HTML as XHTML and they translate CSS to XPath and apply queries over. By the way, what is faster? For example, in the previous year, on past previous year, in Nokogiri, Mike in Nokogiri, yeah, Scrape is parcel. Ali is showing it, and Scrape is parcel is great. It's much. I like it much more than Beautiful Soup because it allows to write XPath and CSS selectors the same as we do in Nokogiri. So, but in Nokogiri in the past or past year, Mike, maintainer of Nokogiri, has written. So it uses libxml, and libxml allows to write something like a plugin to execute over XML3 by using XPath, or XPath allows it. I don't remember. We can also talk about it in some, like we can review it, this pull request. It's pretty interesting. So he has written a custom XPath query for CSS selector. Like instead of using that complex stuff with string manipulation, he has written class containing function for XPath. He has written it in C, and we can Nokogiri invokes contains class function that is like custom. It's not in XPath standard. It's custom functions that libxml can understand because he has written. I can actually. I can actually find the pull request. So he has written a function for libxml, like XPath, and it's like 2 times faster, I guess. So, but still, it's XPath. So I don't know how to name it. So, topic performance. Topic performance, supplement C serialization, improve reading spell, compile read number serialization, read encoding performance. I don't remember. Anyway, we can check it later.
Yeah.
So I haven't compared the and I don't know how JavaScript runtime treats CSS selectors. It's also like my to-do in my to-do list because oh, Sergei, we have a visitor from Facebook. Cool.
Nice.
Nice to meet you, Sergei.
So yeah,
So,
thank you for answering it.
so in my to-do list, to render JavaScript in HTML and return rendered HTML, I wanted to dig into V8 or other browser or other JavaScript runtime and browser runtime to be able, instead of spinning up entire browser, only execute specific parts from the terminal, and that's it. Like if it will be the case, I guess we will use it. So instead of decoding Unicode emojis, instead of decoding like all of the random stuff, hex encoded, decimal encoded, instead of reverse engineering JavaScript, we will just invoke from the terminal, like render this page and return me the rendered HTML string, and that's it.
Yeah, makes sense. Awesome.
But anyway, in some cases, we will still need to do that because we will still need to extract data from inline JavaScript because, for example, some data is collapsed, and for example, people also ask block on Google. When you click on it, only then it expands, and to get data from it, yeah, and it's rendered to the page only when you click. So still some cases. And also Google Images, like when you search for some image and specify image parameters like large, small, big, and dimensions, it responds only with 20 images, and others are hidden, and you click on some stuff, it's rendered on the page, and that's also the reason why we have a bug when on the first page we have like 20 images, then we have the same 20 images duplicated. We have a bug report about that, actually. Instead of extracting data from HTML, we should extract data from inline JavaScript only on Google Images.
Awesome. Thank you so much for showing the process of extracting data from Google Maps, like the search query.
Cool.
Awesome. Yeah, I have a few questions, but for another podcast, like
Sure.
third or fourth.
False.
Yeah.
Okay, then we are wrapping up. So this was a Serp API podcast. Dima has asked me about how to scrape dynamic web pages, how to extract data from Google Maps. Yeah, thank you all for watching. It was fun. And actually, thank you all for asking questions and commenting in the chat, because it was really like, it's the first time I have a live stream with real people. Like previously, I only had several talks on conferences, on meetups, but in live stream, it's much more fun. I hope we will have viewers, like concurrent viewers, on the future episodes. So and yeah, Milos telling that we all are bots. Cool. So we have digged into how Google Maps PB, uh, how Google Maps requests are made, how they build URL parameters. We have partially debugged Google Maps pagination. Then we talked about differences between CSS selectors and XPath queries. We had talked about usages of browser automation, when it's better to use, when it's not, how to speed it up. We have covered a bit different browser runtimes and JavaScript runtimes, and some parts of performance of Nokogiri. And in the future episode of like when we will have this topic in the Serp API podcast, we will probably talk about how to how to actually construct the URL to Google Maps to retrieve the data by using just HTTP requests without using the browser. And it will require debugging, and it will require also some mathematics. And some people on Twitter with name Mindshell asking, where are you from? And we are from Ukraine. And please donate some money to Ukraine. I mean, to armed forces. It's a joke and not joke at the same time. So, no, we are not Russians. Putin хуйло. Слава Україні. Дякую всім дякую захисникам України, дякую усім волонтерам та дякую усім людям, що приближають та наближають перемогу України. This was Serp API podcast. What else? I guess let's wrap up. Thank you all for discussion. Thank you, Dima, for questions. It was fun.
Thank you for having me. I appreciate it.
Cool. Yep. Thank you, Mindshell. Thank you.
Yeah.
So I'm clicking end stream.
Yeah. So see you.
See you in the probably next Friday, because Serp API podcast is hosted every Friday. Okay.
Got it.
Good luck.
Yeah. See you next time. Cheers.